graph and solve quadratic inequalities. So I know you said that there wasn't a notes video because it's like super short, so I'm just going to give you this information really fast. So quadratic inequalities in two variables. So if we have something like y is less than ax squared plus bx plus c, this would be dotted, and we would shade outside the parabola. So we've done like linear inequalities before, now we're on quadratic inequalities, so graphing parabolas that are inequalities. If we had y is greater than ax squared plus bx plus c, this is still going to be dotted, but we would be shading inside the parabola. If I have y is less than or equal to ax squared plus bx plus c, it's going to be solid. So it's going to look like a normal parabola when I graph it, and we're going to shade outside the parabola. If I have y is greater than or equal to ax squared plus bx plus c, this is also going to be solid, and we're going to shade inside the parabola. Now, does anyone notice anything about every single one of these?
They're all y is ax squared plus bx.
What do you notice about A, though? What sign's on A? So that means all of these parabolas open up. So these all open up. This information is only true when they open up, okay? Now, if there was a negative sign out front, what I mean by that is that the shading is going to be like opposite because it's now going to open down. So I would say pick a point that's within that and check it and make sure that wherever you're shading is a point that actually works with your given situation. So I'll make sure we have, an example like that, but just wanted you to have it for reference. So, if I can get on the right page, maybe that would be helpful. Okay. The first problems are just like matching, so I'm not going to do those, but if you feel like you want to do them, you can. So number 8, we've got y is greater than x squared minus 9. So we have to go all the way back to, what was it, like 4.1 or something, where we were graphing parabolas in terms of how to find my vertex, axis of symmetry, and all those things. So minus b over 2a is the x-coordinate of a vertex, or my axis of symmetry value. But in this case, b is 0, so this is going to be equal to 0. So my vertex, x-coordinate is 0. That means when I plug in for x of 0, I get negative 9. So my vertex is at 0, negative 9. Axis of symmetry. Now, we don't often draw in the axis of symmetry on these ones just because they're inequalities, but just for reference, kind of more as a review for you, that would be at x equals 0. So I'm going to set up my graph over here. Now, I know I've got to go all the way down to -9, so I'm going to make my graph a little bigger on the bottom. So vertex at 0, -9, so it's down here. So I need to find another point that I can graph, so I would say just pick like 1 or something. Plug in 1, so it's 1 squared minus 9, so that would be -8. So that's going to be here. Means I've also got one on this side over here in the same spot. Now, is this solid or dotted? Dotted because it's just greater than. So these are kind of annoying to draw, I'm not gonna lie, but anyways, something like that. And then I'm shading, okay, so it's greater than, this one opened up, and so that means I'm going to shade inside because that's where it's greater than. Everything else, when you're thinking about y being greater than or y being less than, it's dependent on the whole thing. So if I chose to shade outside, that would make y a lot smaller, but I need this stuff that's filling the inside, which is what makes y getting bigger. So we would shade all in here. Let's see. 10. Y is less than x squared plus 4x minus 5. So minus b over 2a. So I've got -4 over 2 times 1, so that's just going to be -2. So vertex at -2, and if I plug in -2, I get, let's see, -2 squared plus 4 times -2 minus 5, so that's 4 minus 8 minus 5, -9. So -2, -9 will be my vertex. Axis of symmetry would be at -2, x equals -2, but again, we don't really do that with the parabolas for inequalities, but you still need to remember when you go to graph regular parabolas for your test next week that you need to have that. So I know that I need to go down to -9 again, so I'm gonna, again, kind of draw my graph a little off center because of that. All right, so I've got vertex at -2, -9. Then I need to find another point, so I'm going to use 0. So that's 2 away. So 0 would be at -5. So then 2 away on the other side. Now, is this one solid or dotted? Dotted again. Now this one is less than, so I need to go where y is smaller. So y is smaller outside of the parabola. So that means I'm shading out here. And when you shade, you need to make sure you show that it's shaded all the way around. Don't have to be like obnoxious about it, but you gotta make sure you show that it's shaded outside of it. All right, 12. Y is less than or equal to negative x squared plus 3x plus 10. What do you notice right away about this one? It's gonna open upside down. So that means that my shading mindset needs to be its reverse from what we had written because it's gonna be upside down. So working on my vertex, I've got let's see, minus b, so negative 3 over 2 times negative 1. So that's going to be at 3 halves. Love that. Might want to think about this as 1.5 instead. Might make it a little easier. And then I need to find the other value. So I would have negative and then 3 halves squared. And remember, the negative's outside, so it's not getting squared. Plus 3 times 3 halves plus 10. So that's going to be negative 9 over 4 plus 9 over 2 plus 10. So I need to get a common denominator. So it's going to be negative 9 over 4 plus 18 over 4 plus 40 over 4. Which is going to give me 49 over 4. Which is also 12.25 if you want it as a decimal instead. So obviously this one's going to go up pretty high, so I'm going to do the reverse with my graph. I'm going to have it more on the top. So I've got a vertex at 3 halves and 49 over 5, or 1 half and 12.25. So it's going to be up here. Again, I would use 0, which puts it at 10. That's 1.5 away on that side, so I need to be 1.5 away over here. Are we solid or dotted this time?
Solid.
Solid. So this looks more like a normal parabola. Now, where would this one be shaded? Inside. Yep, because it's less than, so it's where y is getting smaller. And that would be on the inside of this one. All right, any questions on this? There's one more thing to do, and then we'll be done. One more. All right, so if you remember when we had systems of inequalities and we had to shade different directions and stuff like that on them, and we were trying to find the overlap where the solution was, we are also going to do that with quadratic inequalities. So we're going to graph two parabolas. 95% of the time they're going to be one's facing down and one's facing up, and then we'll shade in between. So 22, this is the last one, I promise. Y is greater than or equal to x squared minus 4. And I'm going to write the other one over here. Y is less than or equal to negative 2x squared plus 7x plus 4. So these are both going to get graphed on the same thing. So vertex for the first one. This one's pretty easy because b is 0, so that means my x-coordinate is 0. Plug in 0, I get negative 4. So that one is 0, negative 4. Now, what do I know? Ignore the second one. What do I know about this graph? What's going to happen?
It'll open up.
Opens up. What else do I know? Solid or dotted?
Solid.
Solid. And then where would I shade in this? greater than, so it's going to be inside. Now, sometimes it's easier to see that once you've actually graphed it, but I like to try to get as much of this as possible beforehand. All right, this one, vertex. We have minus b over 2a, so that's negative 7 over 2 times negative 2, which is going to be a positive 7 over 4. Or 1.75 if you prefer it that way. And then negative 2 times 7 over 4 squared plus 7 times 7 over 4 plus 4. So that's going to be 49 over 16. No. Yeah. Negative 2 times 49 over 16, which is going to reduce that to an 8. So negative 49 over 8. Plus this would be 49 over 4. I need to make it over 8, so I'm trying to save some writing. 98 over 8 plus 32 over 8. And that's going to end up giving me 81 over 8. And I know that's going to be a little bit bigger than 10, so just for the purpose of graphing. What do I know about this one? What's going to happen with this graph? Opens down. Solid or dotted? Solid. And what about shading? Yeah, it's going to be inside. Yeah, because it's upside down. So the less than is going to be inside since it's upside down. It's it's easier to see with the graph, but I always try to write it beforehand, but sometimes I'm like, yeah, I'm just going to need to come back to this once I can actually visualize it. All right, so I know that in the positive direction I need to go up to a little bit bigger than 10, and the negative direction I need to be down by like negative 4-ish just based on what's given to me. So I'm going to need a decent sized graph here. 11. Okay, so I'm going to do the first graph as blue, second graph I'll make red, and then I'll use the different colors to shade with. So at 0, negative 4, I have a vertex. If I plug in 1 to get the other point, I've got 1 minus 3, or 1 minus 4, which is negative 3. Then 1 away on the other side. Solid, we said, so I'm going to go ahead and graph that. Shading, I'm just going to use a lighter shade of blue. So I shade inside. Then for the other one, I've got a vertex at 1.75 and something a little bigger than 10. So up here, I'm going to use 0, which is at 4. And then I need to go that far away over here, which is like, I don't know, generally speaking, somewhere in there. 3. I went a little too far away. Oh no, undo. I'm just going to have to reshade it. It's fine. Okay, good enough. All right, and this one is also solid, opens down. This one gets shaded inside. Are you confused? Did I do something wrong? Okay, just checking. All right, so shade inside. So this overlapped where it looks kind of purple is my solution.
go back up a little bit.
Like that far, or you need me to go farther than that?
No, that's good. Which one is facing that way?
The red one is the second one. The blue one is the first one.
I thought that would be shaded on the outside. But it's less than.
But it
Wait.
opens down. It's less than, but it opens down. So
Freak.
that means where y is smaller.
Again. Sucks.
Correct. That's why sometimes it's easier to just wait till you can visualize it, because can be a little confusing.
Oh, I didn't do that. Great job.
All right, problems 7, 13, 15, 18 and 19, you just need to say what the error is. You don't need to like rewrite the problem or anything. Just basically look and see what they did wrong with their graphing of the parabola, and then 21, which would be a system.
Something about your chin.